Chameleons or chameleons are a distinctive and highly specialized clade of Old World lizards with 200 species described as of June 2015. The members of this family are best known for their distinct range of colors, being capable of color-shifting camouflage. The large number of species in the family exhibit considerable variability in their capacity to change color. For some, it is more of a shift of brightness. For others, a plethora of color combinations can be seen. Chameleons are also distinguished by their zygodactylous feet, their prehensile tail, their laterally compressed bodies, their head casques, their projectile tongues used for catching prey, their swaying gait, and in some species crests or horns on their brow and snout. Chameleon's eyes are independently mobile, and because of this the chameleon's brain is constantly analyzing two separate, individual images of its environment. When hunting prey, the eyes focus forward in coordination, affording the animal stereoscopic vision. Chameleons are diurnal and adapted for visual hunting of invertebrates, mostly insects, although the large species also can catch small vertebrates. Chameleons typically are arboreal, but there are also many species that live on the ground. The arboreal species use their prehensile tail as an extra anchor point when they are moving or resting in trees or bushes. Because of this, their tail is often referred to as a fifth limb. Depending on species, they range from rainforest to desert conditions and from lowlands to highlands, with the vast majority occurring in Africa, but with a single species in southern Europe and a few across southern Asia as far east as India and Sri Lanka. They have been introduced to Hawaii, California, and Florida. In 1986, the family Chameleonidae was divided into two subfamilies, Bruchizinae and Chameleoninae. Under this classification, Bruchizinae included the genera Bruchizia and Rhampholeon, as well as the genera later split off from them, while Chameleoninae included the genera Bradypodion, Calama, Cameleo, Furcifer, and Trioceros, as well as the genera later split off from them. Since that time, however, the validity of this subfamily designation has been the subject of much debate, although most phylogenetic studies support the notion that the pygmy chameleons of the subfamily Bruchizinae are not a monophyletic group. While some authorities have previously preferred to use this subfamilial classification on the basis of the absence of evidence principle, these authorities later abandoned this subfamilial division, no longer recognizing any subfamilies with the family Chameleonidae. Some chameleon species are able to change their skin coloration. Different chameleon species are able to vary their coloration and pattern through combinations of pink, blue, red, orange, green, black, brown, light blue, yellow, turquoise, and purple. Chameleon skin has a superficial layer which contains pigments, and under the layer are cells with very small guanine crystals. Chameleons change color by actively tuning the photonic response of a lattice of small guanine nanocrystals in the S. iridophores. This tuning, by an unknown molecular mechanism, changes the wavelength of light reflected off the crystals, which changes the color of the skin. The color change was duplicated ex vivo by modifying the osmolarity of pieces of white skin. Color change in chameleons has functions in camouflage, but most commonly in social signaling and in reactions to temperature and other conditions. The relative importance of these functions varies with the circumstances, as well as the species. Color change signals a chameleon's physiological condition and intentions to other chameleons. Because chameleons are ectothermic, another reason why they change color is to regulate their body temperatures, either to a darker color to absorb light and heat to raise their temperature, or to a lighter color to reflect light and heat, thereby either stabilizing or lowering their body temperature. Chameleons tend to show brighter colors when displaying aggression to other chameleons, and darker colors when they submit or give up. Most chameleon genera have blue fluorescence in a species-specific pattern in their skull tubercles, and in Bruchisia there is also some in tubercles on the body. The fluorescence is derived from bones that only are covered in very thin skin, and it possibly serves a signaling role, especially in shaded habitats. Some species, such as Smith's dwarf chameleon and several others in the genus Bradypodium, adjust their colors for camouflage depending on the vision of the specific predator species by which they are being threatened. In the introduced Hawaiian population of Jackson's chameleon, conspicuous color changes that are used for communication between chameleons have increased, whereas anti-predator camouflage color changes have decreased relative to the native source population in Kenya, where there are more predators. Chameleons have two superimposed layers within their skin that control their color and thermoregulation. The top layer contains a lattice of guanine nanocrystals, and by exciting this lattice, the spacing between the nanocrystals can be manipulated, which in turn affects which wavelengths of light are reflected and which are absorbed. Exciting the lattice increases the distance between the nanocrystals, and the skin reflects longer wavelengths of light. Thus, in a relaxed state the crystals reflect blue and green, but in an excited state the longer wavelengths such as yellow, orange, green, and red are reflected. The skin of a chameleon also contains some yellow pigments, which combined with the blue reflected by a relaxed crystal lattice results in the characteristic green color, which is common of many chameleons in their relaxed state. Chameleon color palettes have evolved through evolution and the environment. Chameleons living in the forest have a more defined and colorful palette compared to those living in the desert or savanna, which have more of a basic, brown, and charred palette. The oldest described chameleon is Ankyngosaurus brevicephalus from the Middle Paleocene of China. Other chameleon fossils include Cameleo corallicordi from the Lower Miocene of the Czech Republic and Germany, and Cameleo intermedius from the Upper Miocene of Kenya. The chameleons are probably far older than that, perhaps sharing a common ancestor with iguanids and agamids more than 100 Maya. Since fossils have been found in Africa, Europe, and Asia, chameleons were certainly once more widespread than they are today. Although nearly half of all chameleon species today live in Madagascar, this offers no basis for speculation that chameleons might originate from there. In fact, it has recently been shown that chameleons most likely originated in mainland Africa. It appears there were two distinct oceanic migrations from the mainland to Madagascar. The diverse specification of chameleons has been theorized to have directly reflected the increase in open habitats that accompanied the Oligocene period. Monopoly of the family is supported by several studies. Chameleons primarily live in the mainland of sub-Saharan Africa and on the island of Madagascar, although a few species live in northern Africa, southern Europe, the Middle East, southeast Pakistan, India, Sri Lanka, and several smaller islands in the western Indian Ocean. Introduced, non-native populations are found in California, Hawaii, and Florida. Chameleons are found only in tropical and subtropical regions and inhabit all kinds of lowland and mountain forests, woodlands, shrublands, savannas, and sometimes deserts, but each species tends to be restricted to only one of a few different habitat types. The typical chameleons from the subfamily Chameleonini are arboreal, usually living in trees or bushes, although a few are partially or largely terrestrial. The genus Bruchisia, which comprises the majority of the species in the subfamily Bruchizinae, live low in vegetation or on the ground among leaf litter. Many chameleon species have small distributions and are considered threatened. Declining chameleon numbers are mostly due to habitat loss. Most chameleons are oviparous, but all Bradypodian species and many Trioceros species are ovoviviparous. The oviparous species lay eggs 3 to 6 weeks after copulation. The female will dig a hole from 10 to 30 centimeters deep depending on the species and deposit her eggs. Clutch sizes vary greatly with species. Small Bruchisia species may only lay 2 to 4 eggs, while large veiled chameleons have been known to lay clutches of 20 to 210 to 40 eggs. Clutch sizes can also vary greatly among the same species. Eggs generally hatch after 4 to 12 months, again depending on the species. The eggs of Parsons chameleon typically take 400 to 660 days to hatch. Chameleons are preyed upon by a variety of other animals. Birds and snakes are the most important predators of adult chameleons. Invertebrates, especially ants, put a high prediction pressure on chameleon eggs and juveniles. Chameleons are unlikely to be able to flee from predators and rely on cry size as their primary defense. Chameleons can change both their colors and their patterns to resemble their surroundings or disrupt the body outline and remain hidden from a potential enemy's sight. Only if detected, chameleons actively defend themselves. They adopt a defensive body posture, present an attacker with a laterally flattened body to appear larger, worn with an open mouth, and if needed, utilize feet and jaws to fight back. Vocalization is sometimes incorporated into threat displays.